All right, now we're going to do notes over ellipses. An ellipse is just another one of our conic sections. Remember, our four conic sections we're going to be talking about are circles, ellipses, parabolas, and hyperbolas. Those are all called conic sections. Sometimes we abbreviate it and we just say conics. And that's because they're cross sections formed when a double nabbed cone is sliced by a plane. On the circle day, we kind of had some images of that. The general form for our conic sections looks like this. It's ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0, where a, b, c, d, e, and f are real numbers. They're just numbers. Okay, so you're going to need to know from the general form which conic section we're talking about. So remember when we did parabolas, parabolas only had one variable that was squared, either the x or the y. So this is kind of a flow chart helping you figure this out. If either the x squared or the y squared is missing, then you have a parabola. If you have both the x squared and y squared, but one of them is negative, that's going to be a hyperbola. So this kind of talks about it over here. You have both the x and the y squared, and then they're going to be connected by a minus sign. But the coefficients of the x and the y squared, they can be same or different. It doesn't really matter. If your x and your y squared have the exact same number in front, they're both the same sign, then that's a circle. So I'm going to say here, this is same number and same sign. If you have an x and a y squared, but they have different coefficients, but the same sign, then that's an ellipse. So it kind of breaks it down over here. You have an x and a y squared, and the x and the y squared are connected by a plus sign, but they have different coefficients in front. All right, let's look at some of these examples. Okay, so on this one we have an x squared and a y squared. They have the same number in front. They're both the same sign, so that's a circle. Okay, on example 2, we have the same sign but different coefficients, so that's an ellipse. On number 3, we just have a y squared, no x squared, so that's a parabola. On number 4, we have both an x squared and a y squared, same sign but different numbers, so that's an ellipse. On number 5, we have an x and a y squared, different signs, so that's a hyperbola. On number 6, we just have an x squared, there's no y squared, so that's a parabola. On number 7, we have both an x squared and a y squared. They have the same numbers in front, so that's a circle. And then on number 8, we have both an x squared and a y squared, different signs, and so that's a hyperbola. Okay, let's use that to help us. Okay, so we're going to be talking about ellipses. They can either be horizontal and they look like this, or they can be vertical and they look like this. Your major axis is what makes it horizontal or vertical. This right here is your major axis. This right here is your major axis. It's the longer axis. The minor axis is the shorter axis. Okay, so when you've got the equation, we're going to be looking at these equations in two different forms, I guess, when the center's at 0, 0, or when your center is at HK. So when your center's at 0, 0, it's just going to be x squared and y squared, and they'll be over a squared and b squared, and it'll be equal to 1. So I want you to notice that the difference between these two equations. On this one, the a squared is below the x squared. On this one, the a squared is below the y squared. So the difference is, what you need to know is that a is always greater than b. And so whatever the bigger number is on the bottom, if it's below the x, then it's going to be a horizontal ellipse. If the bigger number is under the y, it will be a vertical ellipse. So the same thing happens down here on when the center is something other than 0, 0. If the bigger number is under the x, it's going to be horizontal. If the bigger number is under the y, it's going to be vertical. All right. Okay, on this first example, we can see that our bigger number is under the x, and so that tells me that it's horizontal. My center is at 1, 0. I'm going to erase this highlighting. Okay, so I'm going to plot that center first, right here at 1, 0. Okay, so my a value is under the x because it's bigger, so it's my a squared is 25, which means a equals 5. So I'm going to, because it's horizontal, I'm going to go from the center 5 units on either side of the center. So that puts one point right there, 1 point right there. So my vertices, the vertices are always on the major axis. They're going to be at -4, 0, and at 6, 0. My covertices come from the b value. The b value is 4, so that, or I'm sorry, the b squared is 4, so the b value is 2. So from the center, I'm going to go up 2, and I'll go down 2, and those are the covertices. So they're at 1, 2, and 1, -2. Okay, so now I can graph my ellipse. All right, now I need to talk about the foci, and I forgot to bring that up above. Our formula to help us get the foci is that we needed the c value, and the c value comes from doing c squared equals a squared minus b squared. That formula was up above in the notes, sorry about that. So I'm going to do c squared equals 25 minus 4, so c squared equals 24, or 21. Which means c equals the square root of 21. All right, now what the focus is we have 2 of them, so they're foci. They're within the ellipse, and they're going to be c units away from the center. So you're going to add c units this way and c units this way to get the foci. So they're going to be along this major axis right here, which means that they'll keep the same y value as the center, but you're going to be adding that c to the x value of the center. So I'm going to write it like this. You're going to be adding it and subtracting it. So I'm going to do 1 plus or minus the square root of 21, comma 0. And that's our focus. There's one more thing we need to know about conics that I didn't talk about on the circle today, but it's something called eccentricity. And the way we get the eccentricity is we do the eccentricity equals c divided by a. And basically what that tells you, it will tell you what shape you have. If e equals 0, then you have a circle. If e equals 1, you have a parabola. If e is less than 1, then you have an ellipse. And if e is greater than 1, you have a hyperbola. So my eccentricity for this one would be the square root of 21 over 4. Or I'm sorry, it's over 5 because my a value is 5. And if you put that in your calculator, you'll get like 0.9 something. So it's definitely less than 1, which tells me that that's an ellipse. All right, on the next one, our bigger number is under the y. That tells me it's vertical. My center is at -2, 1. My vertices I'm going to get after I plot that center. So -2, 1 is my center. So this time my a squared equals 16. And so a equals 4. So I'm going to go vertical because it's a vertical one. Up 4 and down 4 from the center. My b squared equals 9. So b equals 3. So I'm going to go horizontally 3 out on either side of that center. So there's your ellipse. So my my vertices were at -2, -3, and -2, -5, or I'm sorry, +5, my bad. My covertices were at -5, 1, and 1, 1. And I still need to find my focus by doing c squared equals a squared minus b squared. So c squared will equal 16 minus 9. which is 7. So C equals the square root of 7. And because this one's vertical, I have a vertical major axis. My x value of my center will stay the same. I'm adding it to the y, I'm adding it to the y's of my center, so it'll be 1 plus or minus square root of 7. And then my eccentricity for this one would be square root of 7 over 4, which again will be less than 1, so it proves it's an ellipse. Okay, on this one, we have a vertex that is at 5, 0, and I'm going to go ahead and graph that. We have a co-vertex at 0, negative 1, and our center is at 0, 0. So what that tells me is that my A value is 5, and my B value is 1. So A equals 5 and B equals 1. So we can write this as x squared plus y squared. It's a horizontal one, so the A squared will go under the x, and then the B squared will go under the y, and remember these always equal 1. All right, on the next one, we have a vertex at 2, 8. So it'll be up here. Your focus is at 2, 2, and your center is at 2, 0. So this tells me it's a vertical one. I know that from my vertex to my center, that's my A value, so A equals 8. And so I know I'm going to have x minus 2, because that's where my center is, squared, plus it'll just be y squared. But because this is vertical, that 8 squared is going to go under the y. And that equals 1. I need to know my B value. This was the focus, and so that's my C value, and C equals 2. So I'm going to have to use C squared equals A squared minus B squared to get my B value. C squared will be 4. It's because this is 2 squared equals 8 squared minus B squared. So that's 4 equals 64 minus B squared. So negative 60 equals a negative B squared, which means B squared equals 60. And that's what's going to go underneath this is the B squared. So that's my equation. All right, let's do another one. Okay, on this one, I know it's a horizontal one, and I know that this is my A value, so A equals 4, B equals 2. My center's at 0, 0, so it's going to be x squared over that 4 squared, so 16, because it's horizontal, that's where the A goes. And then y squared over 4 equals 1. On this one, we've got to determine the center. There's my major axis, there's my minor axis. And so my center will have the same x value as this and the same y value as this. So my center is at 1, 2, and so we're going to do x minus 1 squared plus y minus 2 squared equals 1. And then I know that from here to here vertically, I'm going from 2 down to that negative 1, so that's a distance of 3, which means A equals 3, and it's a vertical ellipse, so that's going to go under, the A squared will go under the y. Horizontally, I'm going from this negative 1 to this 1, which is over 2, so that it means that B equals 2, so that means B squared will go under the x, so it'll be 4 there. On the next example, we have to write it in standard form. So we've got to complete the square. So we'll do x squared plus 6x plus some number plus 4y squared minus 8y plus some number equals, I'm going to move the 9 to the other side and add those numbers to this side. So this, one thing you need though is this to not be a 4. You need it to be a 1. So I'm going to factor out that 4. Okay, now then when I add the numbers to complete the square, I'll do 6 divided by 2 and then square it. So this will be 9 that I'll add to both sides. On this side, I'll do negative 2 divided by 2 and square it, which is 1. But I'm not just adding 1 to both sides, I'm adding 4. So we need to put a 4 there. So this will factor to be x plus 3 squared plus 4 times y minus 1 squared equals 4. So now I know my center is at -3, 1. And I know that it is, oh, I'm not done yet, though, sorry. I need this to equal 1. So right now, this is equal to 4. So I'm going to divide through by 4. That way, the right-hand side will be 1. So that leaves me with x plus 3 squared over 4. Here, the 4's will simplify. That just becomes 1 on top and bottom. So that'll be y minus 1 squared over 1 equals 1. The bigger number's under the x, so I know that this is horizontal. All right. Okay, so I've kind of written through this one. I grouped my x's and my y's together. I factored out the numbers in front of the x squared and the y squared, and then I completed the square. I made sure when I added to both sides, I multiplied the 25 times 4 to get that 100 and the 4 times 1 to get this 4. And then I factored everything, and now I need this to be equal to 1, so I'm going to divide through by 100. And when you divide through by 100, you should simplify these fractions. So the 25 goes into itself 1 time, and it goes into this 4 times. So this becomes x minus 2 squared over 4 plus y minus 1 squared over 25, and then it equals 1. So my center is at 2, 1, and I know because my bigger number's under the y, it's vertical. All right, that's it for these notes. Thanks, y'all.